Thanks everyone for being here. So my name is Mathieu Sarrazin. I'm French, and I'm working for Canonical. Today we are here to talk about infotainment and how we can change the way infotainment is done in automotive. For that purpose, I will have on stage with me my colleague Bertrand is going to join me, and our dear partner, represented by Moritz, that will come later into a panel discussion. So, and afterwards, we will have a Q&A where you would be able to ask any questions, whatever you want to do. All right? So let's start by a bit of Canonical. So you know that maybe already everything runs on open source. The world is running on open source. That is a huge change. A lot of the things are happening there. Most of the AI, for instance, is running on open source. And more than that, the cloud native applications are running on Ubuntu. We have a huge market share. People are running on Ubuntu because it's stable and reliable. 62%, think about it. This is enormous. And more than that, we have also Ubuntu is the most used distribution in the enterprise, not individual enterprise companies, right? And this is the number of software developers you can reach with Ubuntu. Means when you're trying to hire people knowing Linux that can help you to develop your own application, we have much more developers using Linux, using Ubuntu. They know Ubuntu. Now, what is Canonical doing in this? Because you may know Ubuntu already, but the question is, what is Canonical? So Canonical is the company that is behind Ubuntu. That is a company that is creating and maintaining Ubuntu. And what we do, the first thing we do is taking care of the vulnerabilities that you have on your system. Every open source, every software may have some vulnerabilities, right? We are maintaining and fixing the vulnerabilities in Ubuntu so that your system is secured. That's the first thing we do. The second thing we do is being compliant with a certain number of regulation. We have some regulation we are compliant with for the financial sector. We're working on the ones for the automotive at the moment. You have a certain number of compliance that you need, and security is one of them. And because we have the CVEs and the security, that's where it makes sense for us to start with this one. Then we have enterprise management, which means that we have all sort of software services and solutions to help you manage the estate of devices you have, wherever they are, whatever you do with them. And the last thing we do is that we have a dedicated support. So we can offer support to customers. They can call us, they can reach out to us by email, and we will support them. And we have SLAs for that. Is that clear? But everything starts by the hardware. So we have a team on our side, which is called Silicon Alliance, that is working with the silicon vendors to make sure that Ubuntu is optimized on their silicon. We have all set of partners that we are working in, and we are growing that list all the time. Customers are basically coming to us with silicon, asking to get an optimized Ubuntu on their system. And from those silicon, the silicon can land into devices, into desktop, into servers. We are handling all that kind of thing. We have a lab in our services, in our offices. We have a lab where we put all those devices on racks, and we're testing for regression on a regular basis, making sure that the CVEs are not impacting those devices, that they are still stable, and that the customer can consume the updates without breaking their system. Now, I don't know how far you know about Canonical, but the specificity of Canonical is that the company was created in 2004, and in 2006, there was the first version of Ubuntu, the first LTS version of Ubuntu, which means it's long-term supported. And since then, every 2 years, we've been releasing a new version of Ubuntu. And every version of Ubuntu is maintained long-term. You see the duration, the black arrows. We are supporting now up to 12 years. And again, as you see here, it did not start it yesterday. This is something we have a long track record of doing. And what does it mean? Long-term support means, as a comparison, the Linux kernel is supported for 3-4 years. If you're using Yocto, the Yocto community is supporting for 5 years. We are supporting for 12, which means that whatever version you're using at some point, you have a version of a package that is supported inside an Ubuntu LTS. We will backport any CVE, any vulnerability, we will backport it to that version. So you don't need to upgrade your system to take the latest version of the APIs and then manage the dependencies. You can stick with the same system. We will just apply the patches for security. So you don't have to retest for compliance everything. That's a huge value in automotive. The other thing that is interesting is that if you know Ubuntu, you may be using it on a machine that we never saw. Most of the customers that we have are using Ubuntu on a computer, on a server, on all sort of equipment that we never saw. But still, we are providing updates and security patches. And the challenge we're solving is basically securing those machines, even though we haven't seen them. So if you think about the automotive that is usually building an ECU, they have full control of the ECU, they have full control of the software. That sounds a bit more easier than what we're doing here with unknown hardware. But we don't do only Linux, because no one is running Linux alone. People are using open source and they want new packages added. So we're growing every day. We're adding new packages that are requested by customers in different forms. So we're increasing the scope of what we're covering. These are packages related to AI/ML because our customers are asking us more and more AI/ML support. So the same thing here, we are securing those packages. We are not creating the packages. We are integrating them into the Ubuntu repositories to make sure that they get the CVE patches that they need. So this slide gives you an idea of how big is the stack that we are taking care of. You got the Ubuntu LTS, the one that you find on our website is supported for 5 years, and that's about 3,000 packages. But as I said, people are consuming open source on top, and they want security for that open source. So that's the reason why it goes to 30,000 packages. That's the entire spectrum that we are covering in terms of 8, and we are supporting for 12 years. Any kind of things like that. And most of the people that are using open source are using several of those packages. They're using Grafana, they're using TensorFlow, they're using Kubeflow, they're using all sort of things, depending on the workload, depending on the type of device they're using. Is it a server? Is it an edge device? Is it even a computer? So we are supporting all those things for them. And the thing that you see on top, which is Everything LTS, is basically what we're doing for some of the customers, and Electrobit is one of them, where the customer is coming to us and saying, well, it's fine, you have 30,000 packages, that's great. But you know what, I'm using those 2 additional packages that are not supported yet by Ubuntu. Can you do something about it? And that's what we call Everything LTS, where we take the request from the customer and we include those additional packages into the repository we support. So next time you see a presentation, it's going to be something bigger than 30,000 because we are growing that all the time on a regular basis. And there's no limit. It means we can grow as much as the customer needs, as long as they want. We can do that. So this is what it is about what we do and what Canonical is basically doing. Now, down to automotive. In automotive, people are consuming Ubuntu in different manners, in different places, from the designers of systems. Should it be the CAD design, the system design overall? Should it be cloud activities, software development, but even in the manufacturing plants where they're using autonomous robots, for instance, or they're using all type of devices. They need to try the system. They do some scanning of the products that are completed. All that kind of thing they can run Ubuntu in, and in vehicle as well. Right? But today we're going to talk a bit more about the infotainment piece. So that's where I will ask my colleague Bertrand to come and join me on stage so that he can talk to you about infotainment. Thank you, Bertrand.
Thank you, Mathieu. So hi everyone, for those who missed the beginning, I'm Bertrand Boisseau. I'm the product manager and sector lead for Automotive at Canonical. And for those of you who listened to the first part, Canonical is very proud of working towards the best developer experience possible. So today we're going to talk about infotainment. And before we dive into the heart of it, I think it's important to give you a glimpse of the past 15 years in terms of infotainment operating systems. So around 2008, Windows CE was kind of one of the major players when it came to infotainment systems. It had its pros and cons. Then there was a big wave of Android systems around 2012. Well, it was very, very forked in a way that all the key components weren't Android per se, right? Whether it's the phone, the Bluetooth, or radio components, everything was more or less customized. Then we had around 2019 a small wave of Genevi-based systems. So Genevi is the OS that has the same name of the consortium it originated from. And since 2022, we are seeing a huge wave of Android-based infotainment systems that are using AAOS for Android Automotive OS. This is pushed by Google with the Google GAS, Google Automotive Services, which include the Google Play Store, Google Maps, and Google Assistant. At Canonical, being a Linux-focused company, we do believe that in the coming years, Linux will play a more central part in the in-vehicle systems, whatever ECU and gateway you want, and maybe in infotainment. But for now, it's clear that Android is the leading player right now. So how do we help Android developers on that part? So first of all, we need to understand why Android is picked. The first reason is pretty simple. Android gives you access to millions of apps. So whether you choose to go with the Play Store from Google, in which case you're limited to the pre-validated applications, or with a third-party store, or managing your own OEM store, in which case you will have to handle all the APK deployments and updates and whatnot. There are tons of ways to get your app on your vehicles, on your fleet. The second element to keep in mind is that all the OEMs have already developed tons of Android apps, whether it's for a smartphone, smartwatches, tablets, in-vehicle systems, and some of them invested millions of dollars doing so. So obviously they will want to have the best return on investment when it comes to Android apps. So they won't throw all this in the trash. So we need to stick to Android for now. Also, the market share is very clear. As of today, AAOS represents 35% of the market share in terms of infotainment OS. And it is expected to almost double by 2028. I think it will double by 2030 unless there's, a key change that we didn't anticipate yet. So we have to deal with that and we have to take it into account. Now, there are challenges when it comes to infotainment development, not just for Android, but these are typical that we see day to day when we discuss with OEMs and tier ones. The first one is what I call hardware dependency. Whether you're building a bench or a prototype, you want to make sure that you have the right hardware with the right configuration and the right parts. Everything has to be plugged together. And whether it's for semiconductor shortages or simply because the hardware hasn't been produced yet, well, it's very difficult to start testing on a bench, right? And more often than not, you have to share the bench with multiple teams. It's a struggle. So it's very, very complicated on that point. The second part is the logistical complexity. Usually you're going to have teams spread throughout the world in multiple countries, and you want to make sure that whatever bench they have over there is representative, right? And that's super tricky because they are facing the same issues that you are with the hardware dependencies. So usually you set it up locally and then you send it away. But as soon as there's a new version for one ECU or component or whatnot, well, you want to make sure that the rest of the system is correctly integrated and follows the same integration processes that you want, right? Or else your tests will not be representative. So that's a big issue. And the third one is what I call customization needs. Whether you're an OEM or a tier one or a tier two, more often than not, you're going to have a lot of customization, whether it's from an UI UX perspective, a system behavior perspective. So let's say you want a specific element popping up on your screen when you shut down the engine, or or when you open the door, et cetera, all of these will imply customization, and you need to be able to test them. Moreover, for each OEM, even for even one type of vehicle, you're going to have tons of variants, which means a lot of different hardware configurations that you need to take into account. So when you're a tier one, it starts to get really tricky when you have to manage n number of images. Now, enter Anbox Cloud. So Anbox Cloud is not a new product per se at Canonical. We have been working on Anbox Cloud for the past 8 years and see it as a cloud-native Android. We use it mostly for cloud gaming. I'll get back to that part. I think it's important to mention. The advantage of having, well, a cloud-native Android is that you can scale it at will, and it's always consistent because you can reproduce the exact same configuration any number of times you want on hundreds, if not thousands of instances if you want, which means that you can start testing and seeing your software and your Android image or Android apps immediately without having to wait for a hardware to be ready, without having to wait for your expert to be sent over to whichever country that has the bench. So basically, it gives you a shorter time to market. And this is my favorite one. It runs on any cloud. We are cloud agnostic. Even more, if you want to run in a bare metal, you can do so. So that's not for automotive. So what did we do? Yes. So we've been working for the past year on automotive features for Anbox Cloud. So we worked with Electrobit as our partner. We did some surveys with tier ones and OEMs to understand their needs. And typically what we've implemented, and we've announced this last week, are a couple of key automotive features. The first one is that we support officially AAOS, so Android Automotive OS, not just the regular AOSP Android open source project. And we even provide reference Anbox images for AAOS. So if you have Ubuntu Pro, you can try it out right now and play with AAOS on Anbox Cloud and see how the automotive Android behaves. But usually, as I mentioned, you're going to want to have support for your custom image. So what we offer is a way to make sure that your custom image runs perfectly on Anbox Cloud. We take you by the hand and make sure that everything is perfect and so it runs smoothly. So I'll get back to that part, so that you can test with any type of configuration how your image behaves on these different instances. So here, what you can see is a regular or reference AAOS image running in the cloud, right? My favorite part is the VHAL properties on the right. So what we did was we understood that it was not enough just to be able to run Android in the cloud, even though the way we do it is kind of specific. We understand that the need for OEMs and tier ones is also to have the system interact with the vehicle. So in AOS, what appeared was what is called the VHAL, the Vehicle Hardware Abstraction Layer, which basically is the interface between the OS and all the other vehicle ECUs and components. So let's say you want to see how your system behaves when the car starts driving or brakes, or when you open a door, or when it's nighttime, you can do so. And so we can support virtually any type of interface that you have in the vehicle with any type of ECU, right? And immediately you will see how your image or apps react to that change in the vehicle. We really think this is a key point. So the main benefits that we offer compared to the rest of the competition, well, this is a small view, but it's, I think, the ones that are super interesting. We support all vendors in terms of GPUs, including NVIDIA. We work on any cloud and any type of architecture, including ARM. We are scalable with a very high density per machine. So obviously it depends on your needs, and you want your machines to work in the right performance. So you're going to have to tune that depending on your needs. I mentioned cloud gaming. That's super interesting because, well, due to that use case, we had to ensure that the stream of your Android instance had the very best level in terms of latency. So we ensure ultra low latency. We have a video online. It shows you exactly what you can get in terms of performance. It's super fast. Canonical being Canonical, we take security extremely seriously. So we have enforced security measures when it comes to Anbox Cloud, including TLS and privileged containers approach. We can discuss it at our booth. We have a lot of other security efforts put in place. And with Canonical Ubuntu Pro offering, you get access to 24/7 support so that we can help you every step of the way, anytime, anywhere. And well, this is typically what you will see at our booth. So this is a screenshot of the Electrobit truck Android image. So this is AAOS. It's a custom EB image running on an Anbox instance. Don't take my word for it. You can come at our booth. We have a demo. We have multiple other demos, but we have specifically this one. You can play with the VL properties and see how the Electrobit image reacts, and all the other apps react, by the way. And yeah, that's it for me, I think. So maybe I'm going to call back my friends on stage, and we're going to have a quick chat. And if you have any questions, we'll be happy to answer that at the end.
So thank you, Moritz. Maybe you should start by introducing yourself, because Bertrand introduced himself. I think I did as well. So please.
Sure. Hello, my name is Moritz Neukirchner. I'm heading strategic product management for software-defined vehicles at Electrobit. So I'm very passionate about transforming the way that we develop software. When I look at software development practices in automotive, we have to be more agile. We have to get faster. We have to rely on virtual testing a lot more. We want to go open source because we'd rather like to collaborate on source code rather than requirement specifications. So this is something that we are really passionate about, of driving towards a more seamless, more efficient developer experience.
Thank you for this introduction. So maybe we should tell the audience about why you are here. Why have we decided to call you to come here, and why you decided to come as well? I think we should start with the partnership that we have together, the two companies. Do you want to start explaining what it is? Maybe it's a good.
Sure. So as Mathieu introduced, Canonical is deep expert in Linux, in deploying Linux to critical infrastructure. Everyone trusts their bank that they don't lose your money. Well, guess what? There's Linux, there's Ubuntu running underneath. So why not put this thing into a car? Why can't we trust it enough with our car data, with our car operations? So in the end, what we have done is we created an automotive-specific Linux distribution that complies with the regulatory requirements that we have in automotive. So I'm talking about the new R155 UNIC regulation on cybersecurity maintenance. And the newest thing that we just released is a Linux for safety applications, enabling us to actually execute safety critical functions on top of Linux. So we're really talking about an open source operating system that we can now use to run critical software. And when we now look at the Android story, obviously, well, where does this go? A cockpit is not just Android. It typically combines Linux as well as Android in a lot of modern cockpits. And this is where you also have safety requirements. So we want to bring these two worlds together to actually create a compelling cockpit experience for all customers, so that you can also open up an ecosystem and install fleet management solutions to operate your fleet more efficiently, for instance.
Right. Thank you. Yeah. So just another way to rephrase the partnership we have is basically a combination of their expertise in automotive and our expertise with open source, where they came with some specific requests. They had their own technology. They bring it together with what we provide to basically bridge the gap between the two worlds and provide the best of the two. That started with Linux, with EB Cobos Linux, and that is extending here with the Anbox Cloud, where they provided their version of AAOS and combined with our tool. So that's a nice way to work together, honestly. Bertrand, do you want to add something?
Yeah, I think it fits nicely with what Moritz said at the beginning. More and more, the development will move to the cloud and be hardware agnostic, not just because, well, for fun or because we have hardware complexity, but also I think it fits with the SDV approach, which is basically as much as possible trying to have the software as agnostic as possible to the hardware, right? And decorrelating the two development cycles, right? What does that fit as well?
Yes. So when we look at software-defined vehicles, one of the key points is to be able to decouple software development from hardware development. So if we want to roll out new functions in existing vehicles that we've already sold, well, then the life cycles are no longer coupled. So you can't wait with the next software feature until you sell the next vehicle. That's not what the customer expects these days. So very essential part is to have these development cycles, these development experiences completely decoupled. And obviously a virtualization-based approach for development comes very naturally then, because if it's already decoupled, well, then you can also run it virtually so that you also don't necessarily need hardware in a lot of the validation at development time.
Yeah, that's correct. The other thing that sounds very important for us, because we're coming a lot from the data center, was not to provide you just a replica or a one version of your virtual environment in the cloud. It was making sense as soon as we can scale it. Because what you want is not to buy one server per engineer. That's not going to be cost effective, but it's being able to get multiple clients connecting to one single server and running that in parallel. So then you make also a scale in terms of cost and efficiency. And that's what we can provide with Anbox Cloud in this particular case.
And I want to add on top of that, I mean, we've all been through the COVID time, but with this approach, obviously you can access to the best level of performance from anywhere in the world. You can give that access to, well, anyone from any of your teams. So I think it also adds a lot of flexibility on top of the scalability and consistency that we mentioned. It has this flexibility in terms of development for your teams to make sure that wherever you are on whatever type of device, well, you get access to the same exact image than your colleague that is in Germany, for example, right?
To add on top, one thing that we've seen now in software development is we decrease software release cycles. Software comes faster and faster. That also means we need to run the validation more often. And the problem that we see in a lot of validation is if you couple this software to hardware, you multiply your validation efforts per hardware variant. And then when you increase the update frequency or the upgrade frequency, you also multiply these costs yet again. So having a solution that really makes testing scalable is absolutely essential to have cost-efficient testing and cost-efficient development.
Yeah, that's absolutely correct. Yeah. So still, do you think there will have to remain some sort of hardware tests, whether it's for autonomous driving or key safety features that for regulatory reasons you can't do without?
Definitely. So I wouldn't trust my life to a car that has had software for safety-related functions that wasn't on a test track. I think that comes quite natural. But the question really is, how quickly can you detect errors in development and how quickly can you get them out of the way? So the virtualization story is not about getting rid of all physical testing. It is about speeding up development, about making development more scalable. And this is really the key point.
It's similar to the shift left approach. Oh, sorry. So it's the shift left approach and being able to see all the, well, maximum number of scenarios beforehand, before the car gets on the road or is tested as a prototype. Yeah.
Precisely, yes, yes.
Okay, I think we talked a lot and you may have some questions. So I think we will open the floor for your questions if you have any. Please, we want to break the ice.
Hi, everyone. So you just introduced infotainment development in the cloud. Obviously, a vehicle consists of many ECUs, many components. We have HPCs. How do you see HPC testing in the cloud?
Well, at the moment,
Or multi ECU testing in the cloud?
all right, so let's go step by step. If you're running Ubuntu on the HPC ECU, you can basically, at the moment, you can run Ubuntu on public cloud, or you can run it on whatever server you want, basically, public or private, or hybrid cloud as well. And we're supporting, for instance, the Graviton instances that you have on AWS, which is it's an ARM server. So you can run the same piece of software on the ARM server on Graviton on AWS than you're running on the HPC. Now, the combination of all the HPC that you have in a car is about creating the IPC, the communication channel between those virtual environments in the cloud. So this is something that we don't provide out of the box, but I think this is a service or something that Electrobit is working on through the EB Corbus Linux. I think they have a solution for that. Am I wrong?
Yeah, precisely. So essentially what we can do already today, there is virtualization support for systems based on classic AutoSAR. There's virtualization support for EB Corbus Linux built on Ubuntu. There's virtualization support for Android. And in the end, we can all instantiate these on the infrastructure of a hyperscaler of your choice and connect these virtual instances among each other. So you can still have the test stimuli to the combined system and actually build HPCs or vehicle subsystems in a virtual development environment to actually span these different developer experiences. Because quite frankly, not everything will go to Linux, not everything will go to Android. There's still a good need for classic AutoSAR for very hardware-centric or very hard real-time related workloads. So the point really is, where do you need to cut your simulation into separate partitions? And where do you want to co-simulate for a broader integration perspective?
Yeah, if I may, I mean, I agree with what was said. I think it's the whole digital twin paradigm and being able to move as much as possible to a virtual space what you will have in the physical world, right? Not everything will have to be atomically equal, right? Obviously, that's the whole discussion around environmental parity. Like, how far do you want to be? How similar do you want to be with the physical world? But definitely for key use cases, it makes total sense to move as much as possible. Well, as many ECUs possible in that virtual environment so that you can test it, scale it, push it to the limits that you maybe wouldn't even imagine physically, so that you see exactly how the full spectrum of ECUs behave and how they evolve. There are tons of different use cases based on this approach, like predictive maintenance and whatnot. So I think we'll get there eventually, having all the right parts, the parts that matter with the use cases that matter in the cloud, so that you can test as much as possible in ways that you can't even imagine physically, right?
And since you mentioned one of these use cases, I mean, talking about predictive maintenance, I've talked to companies doing curbside pickup or delivery to trunk services or services for detecting road conditions. And the key point really is, again, about developer experiences. So we do have developers in automotive that need the developer experience of a real-time ECU. We also have the other side of developers who come from IT and want to provide a service that just necessitates to have some software running in the car, but they're not familiar with the development practices of automotive. So then providing a development experience native to where they come from, based on Linux, based on Android, makes a lot of sense, because these people can be way more efficient in development to get started. And a lot of these services don't require deep know-how of the internals, but you actually want to expose vehicle data to these application developers to create value for end customers.
I think that's a great point. I think it's the main challenge in the automotive era today. The two worlds are colliding, like the let's say industrial automotive world and the software/IT world are kind of colliding, and that's what we're seeing every day with the different announcements in the OEM space and in software space. And we'll get there, but it's typically a clash of cultures. And yeah, what we're seeing is the shift is happening whether you like it or not. This is moving forward, and it will help developers have a better experience, have a faster time to market, and hopefully develop at a lower cost with better quality.
Good. I think this is a long answer.
It was a short question.
Is there any other question from the audience? Okay. I think that's a wrap.
Thank you very much. Thank you, Moritz.
Thank you.